next video for this unit is going to look at how energies work together. Because we know that energy just doesn't show up. The kinetic and potential energies that an object may have to come from something. Because according to the law of conservation of energy, we know that energy cannot be created or destroyed. What's going to happen is that it's going to change or transfer from one form to another. The energy into a system has to equal the energy out of a system. And so the example here with the blow dryer, we know that we're going to start with this electrical energy. And as you're using the blow dryer, it's going to turn into thermal energy because of the heat, kinetic energy because of the motor running, and of course we hear the sound. And so for sound, you're vibrating air molecules, so therefore that is energy and kinetic energy as well. Another example would be light bulbs transforming electrical energy into light as well as thermal, because you can feel the warmth around the light bulb. Now that is with the LED lights, that's less of a problem now because they're trying to eliminate that waste, because the thermal energy is not the expected or wanted outcome. It's the light that we want the energy to transfer into. Another example that we can look at would be a spark plug. You've got the chemical potential energy that is sitting in there with the gasoline, and as the gasoline heats up and expands, thermal energy is converted into kinetic energy to make the lever turn to start the car. We know that some energies are very obvious while some are not. And so one of the least obvious that we don't really, or that we take for granted and don't appreciate, is going to be the energy from the sun. That radiant energy is converted into chemical potential energy, which is stored in the chemical bonds in plants. And so we know that this process, that would be called photosynthesis. And when you take biology, you will learn more about this process than you want. There are a lot of details and a lot of steps as far as how that works, but it's something that we take for granted every single day. Now, to look at how kinetic and potential energy work together, we have another name for an energy, which is called mechanical energy. Mechanical energy is just the total amount of potential and kinetic energy in a system. So any system that you might be looking at, whether it's a car or somebody skiing, we can look at their mechanical energy throughout their motion or within that system. And of course, we have another equation, very simple. Mechanical energy is equal to potential energy plus kinetic energy. And so we know that this is energy due to, with potential, it's due to their height above the Earth's surface. And with kinetic, it's their energy due to their motion. So let's look at an example here. And one thing to look at with this, it's a lot of numbers and a lot of different heights, but focus on one of the energies at a time. If you look at the kinetic energy to start out with, because they are not moving, we have a kinetic energy of 0 joules, going back to the unit for energy. And as this skier progresses down the slope, because they're speeding up, because gravity is accelerating them, we can see that the kinetic energy goes up to 20, to 35, and now they're going, if you look up here, they are going uphill, and so we know gravity is going to slow them down a little bit, so that goes down to 20,000 joules of kinetic energy. And as they go down, they're going to speed up, so that when they reach the ground, they're going to be going their fastest speed, which would equal and turn into a larger kinetic energy. Now, if you look at potential energy, if we start out with 50,000 joules, that means their total mechanical energy in this system would be 50,000. And their potential energy, because they're the highest up, is going to be the largest number, 50,000. As they go down the hill, that number goes down to 30, to 15, back up to 30. Notice these are the same height. And then eventually, as you hit the floor, potential energy is going to be 0 because there is no height above the Earth's surface. But with mechanical energy, we know that kinetic energy equals potential energy. And so when you add up these two numbers for the entire trip, they should equal 50,000. And so that's how you look at mechanical energy, whether it's this kind of an example or the blow dryer. They're all going to be equal throughout the entire system or run. Another example of mechanical energy would be when you have any kind of a projectile motion. So with the baseball, As soon as it's hit, it's got low gravitational potential energy because it's closer to the ground and it's going very fast. It's slowing down as it goes up in the air and then speeds up. And so you'll notice that the kinetic energy and potential energy flip flop as far as the total amount in the system. Now, we say that mechanical energy is constant within a system. If it's 50,000, it's going to remain 50,000. But when you look at life and you look at reality, for example, if you are riding your bike and you're coasting, eventually, obviously, you see that you're going to stop. And so the question is, if energy is conserved, if that kinetic and potential energy is going to remain the same in that system, why wouldn't your kinetic energy stay constant so that you would coast forever? If you're not going up or down in height, that means your kinetic energy should stay the same. But we know that's not reality because we've got a wonderful thing called friction. And friction between any two objects that are touching is going to take some of that energy and turn it into thermal energy. When you're swinging on a swing, if you don't keep and use the energy from your body to keep the kinetic energy going, eventually you're going to stop. There's going to be friction between the joints here at the top of the swing, which are eventually going to, as well as air resistance, going to slow you down. And so it seems like the mechanical energy seems to decrease in reality, as if the energy was being destroyed. Now we know that's not a violation because that energy is going to turn into the friction and air resistance. And so that thermal energy is a waste. It goes into the atmosphere and isn't used for anything useful. But that is a part of life, and that's one thing that engineers try to do is to eliminate that friction as much as possible so that energy is not turned into useless energy. Now, the last piece of this puzzle that we're going to look at with energy and the different forms is we look at the body. Now, we don't focus much on this because this is more of a biology concept, but when we talk about energy, this is a big part of where a lot of the energy comes from. And so when we look at the human body, we can ask what kind of energy and forms of energy can you find? And when you look down here, the first question would be your moving arm. What kind of energy is that? Well, if it's moving, that should tell you that it's kinetic. When you're maintaining your temperature, now that's more of an internal process, and so that metabolic process is going to be more of the chemical potential energy. You're going to break down that food, which is then going to turn into thermal. Same thing with the heat, these kind of go together. The heat that your body produces is thermal energy. So there's lots of different forms of energy that the human body possesses. Now, we store energy in the form of your fats and carbohydrates that you're eating. Your body will store that until it's ready to be used. And so you can look at how much energy you need, how much food you need, based on the amount of activity that you do. And so usually in class, we'll look at this or assign this to look at how much how many calories your body needs compared to how many calories you actually put into your body. And so your body converts energy that you eat to heat that is transferred to your surroundings. And so that kind of all goes together when you use that energy to make your body move, to do different activities. And so it all works hand in hand. Now you can look at, depending on your body frame. Now most students, I say, are going to be in that medium body frame, but there are a few that we might consider as the small and some large for their age. But typically I have you look at the medium frame numbers. And just sleeping, it requires 56 calories per hour. Sitting, eating, standing. Now, when you start dancing and you start looking at other activities that are really strenuous, you're going to need a lot more calories during your day. And so it's fun to look at because this is how you gain or lose weight is you look at the amount that you put in versus the amount that you burn or that you use in a specific day. And so it's a neat thing to look at to make sure that you're in the right zone so that you're not gaining weight. Now, when we talk about calories, we all know that calories are what we eat. If you go to Europe and you look at their foods, they don't use calories necessarily. What they use are kilojoules. And so we know that joules are energy, and so there's a conversion that we can use to go and look and see which ones or what's similar between them. And so the food calorie that we use, now it's a capital C, is a unit used by nutritionists to measure how much energy you get from the food. So 1 calorie is equal to about 4,184 joules. And so when you look at how much food you eat, that would be how much energy you would be able to burn, which 4,000 joules seems like a lot, but remember a joule is a pretty small amount. And you can also compare the different types of foods that you eat. Um, Depending on your needs for the amount of activity that you have. Because every gram of fat that you consume can supply 9 calories of energy. Now, think about a burger from McDonald's and how much fat is in there. There might be 40 grams of fat. And so you're talking, 36 or 360 calories of energy that you might get from that one sandwich, and it's probably more than you need. And so um, this should determine the choices that you make when you're eating. Carbs and proteins give you about 4 calories of energy per gram, and so fat does give you more energy, but also your body can't use that much in one time, so they end up storing it. So it's very important to look at which foods to eat and in what amounts so that you do maintain your weight or depending on what your needs are, whether you need to gain or lose. And so this concludes our discussion about energies. And so I challenge you just to look around and look at all the different types of energies that are used in any given day so that you're always thinking about this and knowing the transformations that happen between energies.